So for this, we have y equals the square root of x cubed minus 1 over the quantity x minus 4 cubed. So what you'll notice is that there's not a natural log. So you would have to simplify this in some way. You will learn very soon some other methods to actually take these derivatives, but it would be really long and complicated. And it turns out you don't actually want to do it that way. You want a different way. So when I look at this, I wish that there was a natural log. So because I'm a mathematician, you're a mathematician. If you want there to be a natural log there, then put one there, as long as you do it to both sides. So I'm going to say the natural log of y equals the natural log, and then I have x cubed minus 1 over x minus 4 cubed. Now, because there's a natural log, I can actually break up the right-hand side of the equation. So I know that this square root is really a 1/2 exponent, so I'm going to use that. This is a division. That fraction bar means I'm dividing. So I'm going to rewrite this as the natural log of y equals, and I'm going to bring the 1/2 exponent down, the natural log of x cubed minus 1. Then I have division, so I'm going to have subtraction, and then I've got this raised to a power as well of 3. So I'd say this is 3 times the natural log of x minus 4. Now, each term there is really, really easy to take a derivative of, so we're going to do that. What you need to know is that we are taking a derivative with respect to x, and you'll notice that on the left-hand side of the equation, we have a y, which is not an x. So this is actually chain rule as well. And we will talk about this when we learn implicit differentiation, and you'll see this more. Right now, I'm going to kind of ask you to take me on faith here, but that y is just like a u. So if I do the derivative of the natural log of u, it's u prime over u. If I do the derivative of the natural log of y, that is y prime over y. Just like it is x prime over x, but the derivative of x with respect to x is 1. Right, equals, I'm going to keep my coefficient of 1/2, and then I'm going to multiply that by u prime over u. My u is x cubed minus 1, and then the u prime is the derivative of that, 3x squared. Minus, I'm going to keep the coefficient of 3, so that could actually go into the numerator if I want. I'm just going to say 3 times, and then I have u prime over u. U is x minus 4, and then the derivative of x minus 4, my u prime is 1. Now, this problem is not finished, and the reason it's not finished is because you are trying to find y prime. So to do that, I need to multiply both sides by y, and I'm going to clean up the fractions as I go a little bit. So I'm going to say y prime equals, and then the 3x squared is in my numerator. The 2 times x cubed minus 1 is in the denominator, minus, then this 3 is in the numerator, and I have an x minus 4 in the denominator. Now I'm multiplying both sides by y, so it would look like this, but I want this expression written with respect to x. So what I actually have to do is replace that y with what it's equal to. So I'm going to erase that and come back up here and say, oh yeah, this is my y. So I have the square root of x cubed minus 1 over x minus 4 cubed. So I'm going to say the square root of x cubed minus 1 over x minus 4 cubed. So if we did this a different way, that would actually be multiplied in on each fraction. You might even have a common denominator, and you can see how complex that would be. So I'm not asking you to simplify it. I just want the derivative. So that would be your final answer.